So today's lesson in quadratic equations is how to solve quadratic equations by graphing. Now, throughout chapter 3, we're going to look at various ways to solve quadratic equations. But our first method is going to use the graphs to solve them. Since we've just finished up the graphing section, we're going to continue to follow that through to solve quadratic equations. Now, when we solve quadratic equations, we're talking about an equation that has a power with the highest degree of 2. That's our quadratic equation. So we might have an ax squared plus bx plus c, where the a could be 3x squared minus 4x plus 10. Now, one of the things that you want to make sure that you do is always have our equation set equal to 0. So when our equation is set equal to 0, and I'm asking you to solve the quadratic equations, we are finding the zeros of the function, or where the graph is crossing the x-axis. So we can also say that we're looking for the x-intercepts when we're solving a quadratic equation. So however you're looking for it, we're looking for the solutions when the quadratic equation is set equal to 0. Now, as far as our graphs are concerned, we can get our solutions to be one of 3 ways. Our first way would be if the quadratic equation would only cross the axis at the vertex. If that's the case, then we're only going to get one real solution. However, if the parabola intersects the axis in 2 places, whether it was because the parabola opened up, or the parabola could also be opening down and crossing in 2 places, we could have up to 2 real solutions. The third option would be that if the parabola never crosses the x-axis. So it could do that if it opens up. It can also do that if it opens down. So there's a couple different ways that we can get no real solution. So there would be no real number where the parabola is crossing the x-axis when we are solving. Okay, so when we're solving these, basically, we just have to get a graph going and find where we cross the x-axis. So we're going to look at our first example. You can see that it's already set equal to 0 for us, and it says solve this quadratic equation by graphing. So just like we did previously, I'm going to find where the axis of symmetry is located so I can solve for my pieces. So my axis of symmetry is going to be located when negative b over 2a is equal to our x. So x is equal to minus a negative 3 over 2 times 1. So x is going to be located at 1.5. All right, so now I'm going to make my table of values from that. Now, when I do this, we have typically picked 5 points. Now, in this section, we might need to go beyond 5 points until we actually cross the x-axis. So leave yourself enough space when you're making your table to go over 5, just in case you need to. So I'm going to pick 1.5. I'm going to go to the left, 1 and 0. I'm going to go to the right, so you can see that I went up a half or down a half. So I'm going to go up a half to 2, and then I'm going to go to the next whole number, which is 3. I'm going to take a second and plug these values into that original function. And when I go to graph, if I haven't crossed the x-axis, then I'm going to continue to pick more x values. So here we go. When I plug 0 in, that gives me my y-intercept of negative 4. When I plug 1 in, that gives me negative 6. And if I'm going too fast, go ahead and pause the video and calculate those out. And then pick up where we left off. Okay, so as you can see, we've yet to cross the x-axis. I'm going to begin to plot these. So 0 is going to go to negative 4. 1 is going to go to negative 6. 1.5, there's where my axis of symmetry is located. It's going to go to negative 6.25. 2 is going to negative 6, and 3 is going to negative 4. So I haven't quite crossed that x-axis yet. So I'm going to continue to pick points until I do. So I'm going to pick a negative 1 on the left, and I'm going to keep going to 4 on the right. And when I do f of negative 1, watch what I get. I actually get 0. That's my 0 of the function because that's where my f of x is equal to 0. When I plug in f of 4, it also gives me 0. So I think that I've found my zeros of the function. Negative 1 is going to cross at 0, and 4 is going to cross at 0. So I'm going to go ahead and graph this. But not only does the graph show me my zeros of the function, so does my table of values. Because at negative 1, my function's equal to 0, and at 4, my function's equal to 0. So my solutions to this quadratic equation reach the maximum of 2 solutions, and they are negative 1 and 4. Now, if you want to check those, you can always plug those back into the equation and make sure you get 0. All right, let's look at our second example. So our second example says solve x squared minus 4x is equal to negative 4. Now, the problem with this one is I said at the beginning we have to have our quadratic equation set equal to 0. So I'm going to move that 4 to the other side so that it does equal 0. And I'm going to work with the quadratic equation x squared minus 4x plus 4 is equal to 0. I'm going to go ahead to find my axis of symmetry. My axis of symmetry is going to be located at minus a negative 4 over 2a, or it's going to be located at 2. So I'm going to go ahead and start my table of values. Not knowing how this is going to go, I'm going to put 2 in the middle. I'm going to start off by picking 2 values to the left and 2 values to the right. So go ahead and pause the video and take a few minutes and find your values of these functions. Okay, when you return back, you can see that my vertex here finds me the 0 of the function. So when I go to graph this, I have 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. So this case scenario is where the parabola is only touching the x-axis in one place, and that's at the vertex. So the solution to this quadratic equation is only 1, and it's when x is equal to 2. And again, if I plug that in up at the beginning, that will check my work for myself. All right, we have one last example to do today. Now you've noticed where I've shown you an example where it crosses 2 exact places. I showed you an example where it crosses 1 exact place. Now we're going to look at one more example together. Now remember that it could be a parabola that doesn't cross at all. I didn't show you one of those. Now this one's going to cross when we graph this one, but it's not going to cross on exact integers. So I want to show you what to do when it does not cross on exact integers. So my equation is already set equal to 0. So I'm going to go ahead and locate my axis of symmetry at 6 over 2. So my axis of symmetry is going to be located at 3. So I'm going to build my table of values with 3 in the middle. I'm going to start picking 2 to the left and 2 to the right and see if that finds me any zeros. So go ahead and take a minute and plug those values into the function. 1 gives me negative 1. 2 gives me negative 4. 3 is going to give me negative 5. 4 gives me -4, and I haven't done this today, but I'm going to see and do that check to make sure everything's symmetric. And 5 also gives me a -1. So as of right now, we haven't hit 0. I'm going to start to graph that and then see where we need to go from there. So 2 is going to take me to -4. 3 takes me to -5. 4 to -4, and 5 to -1. Now you can see that we haven't crossed yet, but I am very close. So I'm going to pick one more point to the left and one more point to the right. Now the left is going to give me a +3. 0, 1, 2, 3. So you can see here that I actually cross over 0 to get to that 3. So if I draw my parabola, it crosses from negative values into positive values. So it has to hit 0 somewhere in the middle. So now let me plug in a 6, and if I go ahead and do the math to that, 6 squared minus 36 plus 3 is also going to give me 3. And you can see that I'm once again going to cross over that x-axis when I get between these two values and continue from there. So my parabola is going to continue. Now the problem with this is I am crossing the x-axis approximately here and here. So I don't know those exact points. Now sometimes I can guess and say that it's at 1/2 or 5.5, or sometimes it's going to be harder to find. So for that reason, it says state the consecutive integers between which the roots are located. So that's going to be located between 0 and 1. Here's 0, here's 1. And this is 1, 2, 3, 4, 5, and 6. So my consecutive integers, I do have two solutions. The first one's going to be a value somewhere greater than 0, but less than 1. Notice I list these least to greatest. And the second one has to be greater than 5, but less than 6. Again, I list these least to greatest, putting those into our set notation. So x is going to be a value somewhere between 0 and 1, and somewhere between 5 and 6. Now this is where graphing might not be your best method to solve a quadratic function, but if you already have it graphed, then we can guesstimate approximately where that x value will occur. So in our future or upcoming lessons, we're going to find other methods to solve quadratic equations that will find those exact values. All right, please look for your assignment and send me an email if you have any questions. Have a good day.